Welcome back. You see, there are we have three systems of symmetrical components or symmetrical arrangement of phasors. There are three systems of symmetrical arrangement of phasor. One of these arrangement is a positive phase sequence. That is for symmetrical arrangement of a phasor. We have the positive, then we have the negative also phase sequence, and we have also the zero phase sequence. With the positive phase sequence, you have the system as being three equal phasors with 120 degrees apart, which rotates anticlockwise in the sequence EA, EB, and EC. That is the positive phase sequence. That is one arrangement of a symmetrical phasors. How to arrange a symmetrical a system of a symmetrical arrangement for phasor. Then we have the one for the negative phase sequence, which is defined as three equal phasors 120 degrees apart, which rotate anticlockwise in this sequence. So if it is negative phase sequence, it will be EA, EB, EC. It will take this form EC, EB, and EA. So that is the negative phase sequence. Also, they are spaced apart by 120 degrees, right? But they rotate in the opposite direction to that of the positive phase sequence. Then we have the one of zero phase sequence. This third symmetrical arrangement, which is having the same phase, is a system with three equal rotating phasors. They are equal rotating phasors, right? But the system are equal in length, and the angle of displacement is same. That is, if it is 40 degrees, they will be 40 degrees. That means the displacement between them is 0 degrees. However, because of this result, this system is unbalanced. It's unbalanced because of their resultant. And while the one for positive phase sequence and negative phase sequence are both symmetrical and balanced, for zero phase sequence, the resultant is unbalanced, right? While that for positive and negative phase sequence are both symmetrical and balanced because of their resultant. Now, let's move to the resolution. If we want to resolve an unbalanced three-phase system of phasors into a symmetrical components, that is, if it is unbalanced and you want to resolve it to its symmetrical component, let's take this one as the normal phasor of the original system, phasor diagram for the original system with a positive phase sequence. Now, the original system will be resolved into three symmetrical components, and let's say the original system, which is this, can be resolved into three symmetrical components. They can be resolved into the positive, the negative, and the zero phase sequence. That is, the normal original system can be resolved into those three symmetrical components. That means phasor EA can be resolved into EA naught, which is the zero phase component, plus EA1, which is the positive phase component, which is EA2, which is the negative. So the original phasor can be resolved into these three symmetrical components that we highlighted the other time. And these are the three symmetrical components: zero phase component, and the positive and the negative component. Likewise, you can resolve phase B into three symmetrical components, which is EB naught, which is zero phase component, zero phase component of that particular phasor, and this is the positive EB1, and this is the negative symmetrical component of it. Likewise, you can resolve phase C into the same, which is EC naught plus EC1 plus EC2. So these are the symmetrical components for those phasors of this original system, that is a positive phase sequence system that we wrote out. So when we express this one in the phasor, put it in phasor representation,